This is the third in our sequence of tutorials about equivalence class testing. In this case, we're going to make things a little more complicated by looking at methods that have multiple parameters. So, the question is, how do we do that? How do we test when it has multiple parameters? Well, the way we approach it is to look at each parameter individually and find equivalence classes for each of those. Let's look at an example here. In this case, I want a method that determines whether a student is eligible for graduate school in computer science. The requirements for that are three. One, that they have a bachelor's degree in some field. Secondly, that they have credit hours in computer science that accumulate to at least 40 credits, if not more, and that in those 40 or more credit hours, they have a grade point average of 3.0. Here's how we can state that a little more formally. You can see here is the name of the method, is eligible. It has, as you can see, three parameters. The first one, called completed BS, is of type Boolean, true or false. The second, CS credit hours, is of type integer. And the third, GPA in CS, or GPA in computer science, is double. And notice also that the return type is Boolean. So this method will either return true or false. There are no preconditions, and here is the postcondition. The postcondition summarizes the actions of the method without really telling how to calculate this. This basically says return true if the first parameter says true, and if the second parameter is bigger than or equal to 40, and if the third parameter has a value that's bigger than 3.0. Yeah, let me first ask, can you interpret this specification in English? Take just a minute. What does it really mean? How would you say this in English? Hope you came up with something like this. A student has to have completed a bachelor's degree with at least 40 semester credit hours in computer science and have a GPA in those courses of at least 3.0. Okay, now let's talk about equivalence classes for each of the parameters individually. Obviously, for the first parameter, completed BS, completed Bachelor of Science degree, that just has two values, true and false, so there are only two equivalence classes. What about CS credit hours? Remember, the critical value was 40, so we have at least two equivalence classes, greater than or equal to 40 and less than 40. Of course, now I hope you're thinking about the situation for air classes and what happens if there's a negative value. So let me add a third class here for negative values. We should not have negative values of credit hours. You will notice that the middle one I'm using a different notation here just so that it's easier to fit on the screen. The notation, the square bracket on the left means 0 is included, and the parenthesis on the right means that 40 is not included. So it's an interval from 0 to 40, including 0, excluding 40. And here's a similar situation for the third parameter, GPA in computer science courses. Got the three classes, the air class for our GPA less than 0, there is no such thing, and then a middle class for GPAs from 0 to 3.0, not including 3.0, and then the final class 3.0 and above. All right, now the question is, how many test cases do we have in this situation? How many total test cases do we have? Remember that each test case will actually have three values, a value for each of the three parameters. Does the person have a bachelor's degree? How many credit hours in computer science? And what is the GPA in computer science? For the parameter in BS, obviously there are two classes. For the CS credit hours, 3 equivalence classes, and for GPA and CS, there are 3. How many altogether, though? How many test cases altogether? Did you say 2 plus 3 plus 3, which is 8? If you did, that's not correct. The right answer is 2 times 3 times 3. Now, where did we get that value? Why 18 rather than 8? I hope you're realizing that the answer is that we need to consider all possible combinations of those three. And you can see I've started on this slide and on the next to enumerate some examples, some test cases we might have. Notice I have 3 columns for the parameters and then 1 for the result. When you're specifying test cases, you should always specify the inputs and the expected outputs. So the first row here tells us that the completed BS parameter has a value of false, the CS credit hours -6, and the GPA in CS -1.1, and of course the eligible then is false. In purple are the values that are considered error cases. Obviously we cannot have a negative number of credit hours or a negative GPA. Nevertheless, we need to test those situations. So you can see in this situation that all the first columns are false, and as a result, since none of these cases does the student have a bachelor's degree, all the eligibles are false also. On the next slide now, in this case, the completed BS is true for all values. And again, we have the systematic enumeration of all the other 2 parameters. Notice in the second column that we cover 3 examples of credit hours. The error case with -6, the below 40 case with 15, and the 40 and over case with 41. 3 rows for each. And that's so that we can use in the third column 3 different values of GPA and CS, -1.1, 2.3, and 3.5, and pair those with each particular value of the first 2 columns. And of course, notice for the GPA, we've picked one example from each of the 3 classes, the air class, the example of between 0 and 3, and then the example of case of above 3.0. And of course, in this case, the only value that results in a true is the final one where the person has a bachelor's degree, has 41 credit hours, and has a GPA of 3.5. So now take the third quiz in the series. Thank you.